There's a funny thing about being human. We walk around with this quiet assumption, almost never stated out loud, that intelligence, thinking, awareness, all this stuff going on inside our heads must be sort of inevitable. Like if you leave the universe running long enough, eventually it has to produce something that sits up, scratches its chin, and wonders why the sky is blue. It feels obvious, doesn't it? I mean, look around you. Everywhere you see complexity. Trees assembling themselves from sunlight and dirt. Ants building little cities underground. Your own body, an absurdly intricate chemical factory, quietly rebuilding itself while you sit there eating a sandwich and not even noticing the miracle of it. So the natural thought is, if the universe can do all this, if it can create stars and galaxies and swirling storms on Jupiter, then surely intelligent life must be popping up all over the place, like dandelions after rain. But here's the strange part, and this is what always makes me grin a little. When you actually start looking closely at how things work, the logic flips upside down. Instead of intelligence being inevitable, it starts to look ridiculously unlikely. Not just rare, astonishingly, almost comically improbable. And this is where the puzzle begins. Because on one hand, the universe is huge. Really huge, the kind of huge that makes numbers almost meaningless. There are more stars than grains of sand on all the beaches of Earth. Each one potentially surrounded by planets. Each planet a little laboratory of chemistry running for billions of years. So the intuitive argument goes like this: with that many chances, intelligent life must be everywhere. It sounds perfectly reasonable, but here's the trick, and it's a very sneaky one. It assumes that intelligence is just another step in a smooth ladder of complexity, like this: first you get atoms, then molecules, then simple life, then complex life, then intelligence. Like climbing stairs, step after step, naturally leading upward. But nature doesn't really work like stairs. Nature works more like a gigantic lottery, and not one of those friendly lotteries where the odds are 1 in a million. I'm talking about a lottery where the odds might be 1 in a trillion, trillion. And you don't even know what the winning ticket looks like. Let me give you a picture. Imagine a vast desert stretching as far as you can see. Across that desert are scattered billions of safes, locked metal boxes. Inside one of those safes is a little note that says, "Congratulations! This planet gets intelligent life." Now here's the catch. Each safe has a combination lock with millions of digits, and the desert wind is randomly spinning the dials. Most of the time, nothing happens. The dials spin for billions of years, clicking past combinations that almost work but don't. Every now and then, maybe one safe opens partway, maybe it produces simple life. But to get intelligence, you need the entire sequence of numbers to line up perfectly. And the universe doesn't care. It doesn't try. It just keeps spinning the dials. That's the first little crack in the assumption that intelligence is inevitable. Because when you start to examine the chain of events that had to happen for you to be sitting here listening to this, it begins to look less like a steady climb and more like a bizarre sequence of lucky accidents piled on top of each other. For instance, consider this. Life on Earth started very early in the planet's history, almost suspiciously early. Within a few 100 million years after the surface cooled enough to allow oceans, simple life appeared. So that part, it seems, might not be so rare. Chemistry is clever. Given the right conditions, molecules bump into each other, form patterns, copy themselves, and suddenly you have something that looks a little bit like life. But here's where things get strange. For nearly 3 billion years after life appeared, nothing much happened. No animals, no plants, no thinking creatures, just microscopic organisms doing their tiny chemical business.
3 billion years!
Imagine waiting that long for something interesting to happen. If intelligence were a natural, inevitable next step, like a seed automatically growing into a tree, you'd expect complex life to show up pretty quickly. But it didn't. It took most of Earth's history just to get from bacteria to multicellular organisms, and then even after complex life appeared, intelligence, real, reflective, self-aware intelligence, only emerged very, very recently. In fact, if Earth's entire history were compressed into a single year, humans would appear only in the last few minutes before midnight on December 31st, which is a rather humbling thought. It suggests something important. Maybe intelligence isn't the goal of evolution at all. Maybe it's not something the universe naturally moves toward. Maybe it's more like an accidental side effect, like foam forming on the crest of a wave. Beautiful, intricate, fascinating, but fleeting, and not the point of the ocean at all. And this leads to a wonderfully unsettling question. If intelligence is not the natural outcome of life, if it requires an absurd chain of improbable events, If evolution can run for billions of years without ever producing it, then what does that say about the rest of the universe? It suggests that most planets, even if they have life, might be filled only with simple organisms, bacteria drifting in alien oceans, quietly replicating, never wondering where they came from, entire worlds alive but silent, no music, no mathematics, no curiosity, no one asking why. And when you really let that idea sink in, it changes the way you see our existence. Because suddenly, instead of feeling ordinary, just one intelligent species among countless others scattered across the cosmos, you start to feel something very different. You start to feel improbably lucky, almost like winning that unimaginable cosmic lottery. And that's where the real mystery begins. Because once you accept that intelligence might be extraordinarily unlikely, you naturally start asking, what exactly made it so hard to happen? What were the bottlenecks? The improbable steps? The weird coincidences that had to line up just right? And perhaps the most intriguing question of all, if intelligence really is so rare, what does that mean for our place in the universe? Now, if you'd like, we can keep following that trail, because once you start digging into the details, the story becomes even more surprising and far stranger than most people expect. Alright, so let's keep wandering down this strange trail, because this is where things start to get really interesting. You see, when people imagine life forming in the universe, they often picture it as something almost automatic, like rain filling puddles. If you have water, the right temperature, some chemicals floating around, then eventually life just sort of happens. And to some extent, that's true. Chemistry is full of little surprises. Molecules are not just passive lumps. They have shapes, charges, tendencies. They stick together, break apart, rearrange themselves. It's like a gigantic dance floor where billions of partners are constantly swapping hands. Now imagine a giant cosmic kitchen. Atoms are the ingredients. Hydrogen, carbon, oxygen, nitrogen, all swirling in vast interstellar clouds. Stars ignite, explode, scatter heavier elements across space. Planets form, oceans condense, and inside those oceans, molecules start bumping into each other. Most of the time, nothing interesting happens. They just collide, drift apart, collide again, like strangers in a crowded train station. But every once in a while, something unusual occurs. A molecule forms that can copy itself, and that's a big deal. Because the moment you have something that can replicate, even clumsily, you've crossed a kind of invisible boundary. You've gone from ordinary chemistry into the beginning of life. But here's the subtlety that's easy to miss. That first replicating molecule doesn't have a goal. It doesn't want to survive. It's not trying to become intelligent. It's just a chemical structure that happens to make copies of itself when conditions are right. And those copies aren't perfect. Sometimes they're slightly different. And most of those differences are useless or harmful, so those versions disappear. But once in a while a variation appears that copies a little faster, or survives a little longer, or sticks to surfaces better, and that version spreads. This is evolution in its simplest form, no intention, no direction, just blind variation and selection. Now here's the key point, and this is where our intuition often leads us astray. Evolution doesn't work like an engineer building toward a final design. It works more like a gambler throwing dice. Every mutation is a roll. Most rolls lead nowhere, some make things worse. A very tiny fraction produce something slightly better for survival in that moment. But better for survival doesn't mean closer to intelligence. That's a crucial distinction, because surviving in an environment often requires being simple, not complex. In fact, simplicity is usually more stable. Think about bacteria. They've been around for billions of years, and they're extraordinarily successful. They can live in boiling hot springs, inside rocks, deep under the ocean floor. They reproduce quickly, adapt rapidly, and require very little energy. From an evolutionary standpoint, they're champions. So here's a curious question. If evolution naturally rewards what survives best, why didn't life just stay bacterial forever? Why did it ever become complex? Why did cells start forming cooperative colonies, eventually turning into multicellular organisms? And here's the surprising answer. It didn't happen because evolution was trying to make complexity. It happened because of a series of weird accidents. One of the biggest was something called endosymbiosis, a wonderfully clumsy word for a very simple idea. At some point long ago, one tiny cell swallowed another. Normally, that would just be lunch. But in this case, the swallowed cell didn't get digested. Instead, it stayed alive inside the host. And here's the remarkable part. It started helping. The internal cell produced energy more efficiently, while the host provided protection. They formed a partnership. Eventually, over millions of years, they became inseparable. That internal helper cell is what we now call the mitochondrion, the little energy factories inside your cells today. And this accident changed everything, because suddenly cells had far more energy available. And energy is what allows complexity to grow. Without that strange, unlikely merger, complex life as we know it might never have happened. But even that wasn't enough. For hundreds of millions of years after complex cells existed, they remained single-celled, no animals, no plants, just microscopic life floating around. Why? Because forming multicellular organisms is enormously difficult. Imagine trying to coordinate trillions of cells so they don't just compete with each other but cooperate, specialize, form tissues, organs, entire bodies. Most attempts at that probably failed. Cells that tried to cooperate might have been overtaken by selfish mutants that reproduced faster inside the group, collapsing the system. So multicellularity required not just cooperation, but intricate control systems, ways to regulate growth, prevent cheating, coordinate development. It's like building a city where every citizen must follow strict rules so the whole structure doesn't fall apart. And once again, this didn't happen because evolution wanted it. It happened because, by chance, certain genetic innovations allowed stable cooperation to emerge, and even then it was rare. Multicellular life appears to have evolved only a handful of times in Earth's history. Now let's pause for a moment and consider what we've seen so far. First, life itself required unlikely chemical events. Then complex cells required an improbable symbiotic merger. Then multicellular organisms required sophisticated coordination mechanisms. Each step wasn't guaranteed. Each step was a kind of bottleneck, a narrow gate that most evolutionary paths never passed through. And now we come to an even more extraordinary leap: intelligence. Because here's the thing, complex life does not automatically lead to intelligent life. Dinosaurs ruled Earth for over 150 million years. They were highly successful, diverse, well adapted. But none of them developed technology, mathematics, or science. They didn't build telescopes or wonder about the origin of the universe. Why not? Because intelligence, especially the kind that produces abstract thinking, requires an enormous investment of energy and biological complexity. Your brain, for instance, uses about 20% of your body's energy, even when you're resting. From an evolutionary perspective, that's incredibly expensive. So intelligence only evolves if it provides a strong survival advantage under very specific conditions. And those conditions are quite unusual. You need an environment that rewards flexibility, problem solving, and long-term planning. You need sensory systems capable of gathering rich information. You need social structures that make communication valuable. You need hands or some equivalent way to manipulate the environment. And you need all of these factors to align simultaneously. It's like trying to build a very delicate machine out of pieces scattered randomly across a vast workshop. Most of the time, the pieces never come together. But once in a great while they do. And when they do, something astonishing happens. A species appears that doesn't just adapt to the environment. It starts understanding it. It asks questions. It forms models. It invents science. And perhaps most astonishing of all, it begins to wonder whether it's alone. Now, here's where the story gets even stranger, because once intelligence appears, it doesn't necessarily last forever. But that is a whole other twist in the tale. So tell me when you're ready to keep going, because the next part takes us into some of the most counterintuitive truths about intelligence, probability, and the strange logic of the universe itself. You know, one of the most misleading habits we humans have is that we tend to look backward at history and imagine it as a neat, orderly story, as if everything that happened was somehow meant to happen. We see ourselves here today, sitting at the very end of this long chain of events, and it's almost irresistible to think, well, of course it turned out this way. It had to. But that's an illusion. It's the same illusion you'd get if you shuffled a deck of cards, laid them out in a very specific order, and then said, what are the odds of this exact arrangement? It must have been destined. In reality, every arrangement is equally unlikely. You just happen to be looking at the one that occurred. And this is a key idea when we start thinking about intelligence in the universe. Because when you examine the sequence of steps that led from simple chemistry to conscious beings, something very peculiar appears. Each step wasn't just unlikely. They were unlikely in a very specific way. They depended on extremely contingent events, things that didn't have to happen at all, and that could easily have gone differently. Let's take one of the most dramatic examples. About 66 million years ago, a giant asteroid struck Earth. It slammed into what is now the Yucatan Peninsula with a force so enormous that it vaporized rock, ignited global firestorms, and threw so much dust into the atmosphere that sunlight was blocked for months or years. And this event wiped out about 75% of all species on the planet, including nearly all dinosaurs. Now here's the curious thing. Before that asteroid hit, mammals existed, but they were small, mostly nocturnal creatures living in the shadows of giant reptiles. If the asteroid had missed Earth, if its trajectory had been slightly different, if Jupiter's gravity had nudged it a little sooner or later, dinosaurs might still dominate the planet today. Mammals might never have diversified, primates might never have evolved, and you certainly wouldn't be sitting here thinking about any of this. So intelligence, at least in our case, depended on an astronomical accident, and not just one. There were many. Earth's orbit had to remain stable for billions of years. The planet needed a large moon to stabilize its axial tilt, preventing extreme climate chaos. Plate tectonics had to recycle carbon and regulate the atmosphere. Magnetic fields had to shield life from harmful radiation. Each of these factors isn't impossible on its own, but the probability that all of them align together on the same planet at the same time for billions of years becomes very, very small. It's like rolling a handful of dice and needing them all to land on 6 at once. And here's where things get really fascinating, because even if a planet manages to pass all these early hurdles, even if intelligent life does arise, there's another enormous barrier waiting: duration. You see, intelligence is not just difficult to create, it may be difficult to sustain. Think about it. For most of Earth's history, life was stable and simple. But intelligent technological civilizations like ours introduce entirely new dynamics. We harness vast amounts of energy. We alter ecosystems. We invent powerful technologies that can reshape the planet or destroy it. In evolutionary terms, this is a completely new phenomenon. No other species has ever had the ability to change its environment on a global scale so quickly. And that creates a kind of paradox. The same intelligence that allows a species to survive and thrive also gives it the power to eliminate itself. It's like handing a very curious child a box of matches inside a room full of fireworks. Curiosity drives discovery, but curiosity without restraint can also lead to catastrophe. So here's an unsettling possibility. Maybe intelligent civilizations tend to be brief flashes in cosmic time. They emerge, they advance rapidly, and then within a relatively short period, perhaps a few thousand years, maybe less, they disappear. Not necessarily through deliberate self-destruction, sometimes simply through environmental collapse, resource exhaustion, or unintended consequences of their own technologies. If that's true, it would explain something known as a very famous puzzle. It goes like this. The universe is incredibly old, about 8 billion years. There are billions of galaxies. Many of them are much older than ours. If intelligent life were common and long-lasting, you'd expect the universe to be buzzing with signals, spacecraft, and evidence of advanced civilizations. But when we look out into the cosmos, we see silence. No clear signs, no unmistakable signals, just vast emptiness. This is sometimes called the Great Silence, and one possible explanation is simply this: intelligence is extraordinarily rare. Another is that it's short-lived, or perhaps both. Now, here's a subtle point that often gets overlooked. Probability in evolution doesn't behave the way our intuition expects. We tend to think, given enough time, anything that can happen will happen. But that's not quite true. Some processes are what we call path-dependent. That means the outcome depends critically on the exact sequence of events leading up to it. Imagine walking through a branching maze. At each intersection, you must choose left or right. Most paths lead to dead ends. Only a tiny number lead to the exit. Now imagine that once you choose a direction, you can't go back. Evolution works like that. Each mutation, each environmental change, each random event locks in certain possibilities and eliminates others. So even with billions of years, most evolutionary paths never approach intelligence. They wander into stable, simple configurations that persist indefinitely, which means something very surprising. Time alone does not guarantee complexity. Time simply provides opportunities. Whether those opportunities lead to intelligence depends on a long chain of extremely specific, low-probability events, and this leads to one of the most counterintuitive truths of all. From the perspective of the universe, intelligence might not be the expected outcome of life. It might be more like an extraordinary anomaly, a rare and delicate phenomenon that appears only under very special conditions, like a snowflake forming in just the right pattern, or a perfect rainbow appearing at precisely the right angle of sunlight and water droplets. Beautiful, but fleeting. And when you start to see intelligence this way, Not as an inevitable product of evolution, but as a fragile accident, it changes how you think about our place in the cosmos. Because suddenly, the question shifts. Instead of asking, why isn't intelligent life everywhere? You begin asking something much more profound. How on earth did it happen even once? And when you really sit with that question, it leads you to a strange and humbling perspective about existence itself. Because it suggests that consciousness, the very ability to experience, to wonder, to ask questions, might be one of the rarest phenomena in the entire universe. And if that's true, then the story doesn't end with probability or evolution. It ends with something much deeper, something that touches on meaning, time, and the extraordinary fact that the universe has, in at least one small corner of itself, become aware of its own existence. And that is where the final part of this journey takes us. And when you really let that sink in, not just as an abstract idea, but as something you feel, it produces a very peculiar sensation. It's a mixture of humility and astonishment, because think about what we've uncovered together. For billions of years, the universe existed with no eyes to see it. Stars burned, galaxies collided, planets formed and were destroyed. All this enormous drama unfolded in complete silence, not silence in the sense of sound, but silence in the sense that nothing was there to notice it. No one was watching, no one was asking questions, no one was saying, hey, that's interesting, why does that happen? And then, on one tiny speck of dust orbiting an ordinary star in a rather unremarkable galaxy, something extraordinary occurred. Matter began to arrange itself in a way that could think. Atoms, which normally just bounce around obeying physical laws, somehow formed structures that could look outward at the universe and also inward at themselves. That's an incredibly strange situation when you really think about it. Because at the most fundamental level, your thoughts, your memories, your curiosity are made of the same stuff as rocks, air, and distant stars. There's no special ingredient, no magical substance added, just ordinary particles following ordinary physical laws. And yet out of that ordinary stuff, something has emerged that can ask, why do I exist? That's one of the most astonishing transformations in all of nature. It's almost like the universe found a way to fold back on itself, to become aware of its own processes. Now here's where things get really subtle, and where the story takes a turn that many people find both unsettling and strangely beautiful. If intelligence is as unlikely as it appears, if it depends on an almost absurd chain of accidents, then consciousness itself might be extraordinarily rare in the cosmos. It might not be scattered everywhere. It might not fill the universe. It might exist only in a few isolated pockets, or perhaps only in one. And that possibility changes everything about how we think of ourselves, because we often imagine that we're insignificant, just tiny creatures on a small planet in a vast universe. And physically, that's absolutely true. We're incredibly small compared to galaxies, nebulae, black holes. But in another sense, a very important sense, we might not be insignificant at all. Because if consciousness is rare, then wherever it appears, it becomes something profoundly special. Not special in a mystical or supernatural way. Special simply because it represents something the universe almost never produces. Awareness, experience, understanding. It's a bit like this. Imagine a gigantic, endless library filled with books, trillions upon trillions of volumes, but almost all of them are blank. Page after page of empty paper. Then, in one corner of this enormous library, you find a single book with writing in it. Not only writing, but stories, questions, ideas, reflections. That book doesn't become important because it's physically large or powerful. It becomes important because it contains meaning. And intelligence is something like that. It's where meaning appears in an otherwise indifferent universe. Now, there's another twist here that I find deeply fascinating. If intelligence is rare and fragile, it also means it might be temporary, not just for civilizations, but even on cosmic timescales. Stars don't last forever. Planets eventually become uninhabitable. The universe itself is evolving, expanding, cooling, slowly running down its supply of usable energy. So there may be only a limited window of time in which intelligence can exist at all. A kind of cosmic season during which life and awareness are possible. And that season might be relatively short compared to the full lifespan of the universe. This leads to a very curious thought. We might be living during one of the most interesting periods in the entire history of existence. Early enough that stars still shine brightly, heavy elements are abundant, and planets can support life. Late enough that complexity has had time to evolve. Right in that narrow window where consciousness can flourish. In other words, we're not just in a random moment. We're in a moment when the universe is particularly capable of producing observers, and that makes the present time, this era of thinking beings, incredibly unusual. Now, you might wonder, does any of this imply some grand purpose or intention? And here's where we have to be very careful, because it's tempting to leap from rare to meaningful in a cosmic sense. But rarity alone doesn't imply intention. Snowflakes are rare and intricate, so are diamond crystals. They form not because the universe wants them, but because physical laws allow them under certain conditions. In the same way, intelligence may simply be a natural, though extremely improbable, outcome of the laws of physics interacting over immense stretches of time. No cosmic plan required, no predetermined goal, just possibility unfolding. And yet, even without a grand cosmic purpose, something remarkable remains. Because once intelligence appears, it creates its own layer of meaning. It begins to explore, to learn, to create art, science, and philosophy, to reflect on its own existence. In a sense, intelligence generates meaning internally, the way a candle generates light in darkness. It doesn't need the universe to provide meaning. It produces it. And that's a profoundly empowering idea, because it means that even in a vast, indifferent cosmos, conscious beings can create value, understanding, and beauty. They can transform blind physical processes into knowledge. They can turn random events into stories. They can take a universe that simply is and ask what it means. Now here's perhaps the most astonishing realization of all. Everything we've discussed, probability, evolution, cosmic accidents, leads to a very simple but breathtaking conclusion. The universe has, in at least one place, become capable of knowing itself. Through your eyes it sees, through your mind it understands, through your curiosity it investigates its own laws. And that's an extraordinary situation, because it means that intelligence isn't just a byproduct of the universe. In a very real sense, it's a new level of organization, a new phenomenon entirely. Matter that can reflect on matter, energy that can contemplate energy, a process that can study itself. And once you see things this way, a quiet shift happens in how you think about existence. Instead of feeling small and meaningless in a vast cosmos, you start to see something different. You start to realize that the size of the universe doesn't diminish the significance of awareness. In fact, it may amplify it, because the larger and more indifferent the universe is, the more remarkable it becomes that something within it can experience wonder. And that brings us back, in a gentle way, to where we began. Intelligent life may be unlikely, extraordinarily unlikely. It may depend on a fragile chain of improbable events stretching across billions of years. But precisely because of that improbability, its existence carries a unique kind of importance. Not because the universe demands it, not because it was destined, but because it represents something rare and precious, the capacity to ask questions, to seek understanding, to feel curiosity, to look out at the vast darkness and say, what is all this? And perhaps the most beautiful part of the whole story is this: the universe does not answer that question for us. It gives us the laws, the clues, the patterns. But the act of discovering, of exploring, of wondering, that part belongs to us. So in the end, the rarity of intelligent life doesn't just tell us something about the universe. It tells us something about ourselves, that we are not merely passive observers drifting through existence. We are active participants in a grand unfolding process, one in which the cosmos, through us, has gained the ability to reflect on its own story. And when you really think about it, that might be one of the most astonishing outcomes that the laws of physics could ever produce.